This starts lesson 6.7, graphing quadratic inequalities, part B. Now let's take a look at an applied question. We have a ball that's being thrown upwards, and it will follow a parabolic curve, and this represents the parabola. It tells us the rate already at which it's thrown, and that's already put into our formula. And what we're wondering is, when is it within 15 feet? And we're going to consider that less than or equal to 15, because it is within 15 feet. It will include 15 in this case. Now I'm going to put this in standard form. I'll say negative 16x squared plus 40x less than or equal to 15 feet. Now as is, we know it's going to open downward, so the negative 16. And we're wondering the path. When is this path going to be below 15 feet? Within 15 feet. Now what we're going to do is we could figure that out as is right now, but since we're working on quadratics, let's bring the 15 to both sides, or to the other side. We'll do that by subtraction. And we'll graph this. Now what this has done is it has shifted the whole graph in such a way that now we're talking about the x-axis instead of just the line of y equals 15. And now we're looking at our roots and a typical problem like we've had already. So if we graph this, and I go negative 16 x squared plus 40 minus 15, and graph it, and there's our parabola. This looks a little bit off still. Oops, there it is, forgot my x. $40x. There you go, minus 15. You could have told me. Alright, now let's try it. There, that looks better. Now we care about when it's below the x-axis. So let's zoom a little bit. I'll zoom in. And then I'm going to move my cursor over to see that it is about there where it starts to go below. So if we consider 0 time and not having negative time, we would say that it would be below 15 feet on the way up, and that would be between 0 and 4.8 seconds. Okay, and if we look at the right part of the parabola where it comes back down, it looks like at 2 seconds and to the right. So we'll say also when x is greater than or equal to 2 seconds. Now I know that it won't stay, the time doesn't go on forever, but we'll just leave that one as x greater than or equal to 2 and not worry about after that. So this is the interval at which the parabola is below the x-axis. So this part and this part. And again, we have this part here because we can't have negative time. Okay? Now so far we've used our calculators, which has been really handy. How do you do this algebraically? Well, we've tended to do a lot of solving algebraically in the past, so this shouldn't be a big stretch for us. But we do have to consider a couple of things. First of all, is it factorable? If it isn't, we can always use the quadratic formula. Plus minus is plus minus. Factors of 2 that have a difference of 1 which will be 2 and 1. We want a positive 1, so make the bigger number positive. That gives us two solutions of -2 and a positive 1. Now if we go on a number line, here's 1, here's -2. If you remember back a couple lessons ago, what we've done here is we've created critical points, and we need to check the zones. So we plug in a -3, and we'll check that one. Plug in a 0, and we'll check that one. And plug in a 2, and check that one. So -3 squared plus -3. I'm going to go right to the original equation here, or inequality. 9 minus 3. So is 6 less than or equal to 2? No, that is false. So it's not going to be in that area. We check the next one. We got 0 squared plus 0 less than or equal to 2. So is 0 less than or equal to 2? That is true. So far that works. We have a 2 to plug in, so 2 squared plus 2 less than or equal to 2 gives us 4 plus 6, 2, which is 6. And 6 is not less than or equal to 2, so that is out. So our solution will be between and including -2 and 1. So checking our zones, something we've done before, but now with a new application.